Hello everyone and welcome to this session on modeling of a concrete building for advanced analysis and design. I am Surajit Ghosh and today I'll demonstrate how we can model a building structure with all required components using RAM structural system. I'll start with a basic introduction and some useful feature of this product required for any building structure, like consideration of dual framing system with floor diaphragm, inclusion of wind tunnel data, construction stage and drift analysis. For concrete element design, we'll use multiple interconnected modules including RCDC and RAM concept. How we can transfer the model and analysis result to these modules and perform concrete design, that will be covered, along with transfer of data to other product with iTwin file, including data exchange with Revit or Open Building Designer. Even import a StatPro model for advanced analysis like construction stage analysis. I'll use this multi-story concrete building for the demonstration. It has a plaza level with dual height floor. Rest of the floors can be utilized for residential or commercial purpose. Structurally, it has a dual framing system with a shear core and rigid floor diaphragm modeled with finite element mesh. Different loads are applied on the structure, including gravity, lateral and construction stage load. To model and design this building, we have used multiple interconnected products. For modeling and analysis, including dynamic, construction stage and drift, we have used RAM structural system. Advanced Concrete Designer or RCDC is used for concrete element design. For elevated slab and raft foundation design, RAM concept is used, which is also a finite element software. In RCDC module, all required concrete drawings are generated along with BBS. Similar drawings are generated in RAM concept. For 3D river arrangement and drawing, ProStructure is used. Model data can be forwarded to this module using an iTwin file. Let's start with a brief introduction of our building design product, RAM structural system. This module is specialized for any type of building design project. A concrete high-rise structure or multi-story steel building with composite deck. It has different interconnected modules for steel, concrete and foundation design. RAM structural is used for different large-scale building design project, including Dhirubhai Ambani Convention Center in Mumbai. There are several other projects like 22 Bishopgate in London or the iconic Shard, a 72-story structure located in central London with 116 feet height, designed entirely using RAM structural. We will explore the floor plan and framing system of this building, how it is modeled in RAM. In RAM structural, we can work with different floor plan and elevation to create a 3D structural model. It has a CAD-like interface where we can activate multiple grids, use construction grid for quick drawing, and stitch different floor plans together. RAM is a finite element software. We can define the mesh as a physical surface. Program internally mesh the area based on connected element. This physical modeling approach gives freedom to customize the mesh at any point of time and eliminate any connectivity issue. For example, we can create an opening in the floor or shift any member location after mesh generation without affecting the mesh. To create this model in RAM structural, we have modeled different floor plans. At the plaza level, floor slab is discontinuous. There are multiple isolated column and member. At the second and third story level, floor plan is different. It has a curved area, a shear core with lift and stair cutout, some ducts for utility. There is also a typical floor plan with similar type of arrangement. Finally, a roof level with different member arrangement. Multiple grids are used to generate this floor plan. We can even create a temporary construction grid for faster modeling. If a CAD file is available with the floor plan, we can import that directly in RAM. After the floor plans are created, we need to define the story level with plan details. Program internally stitch all the floor plans to form a 3D structural model. Later, we can edit any floor plan, Accordingly, the model is recreated. In each floor plan, there are two different colored members. Some beam and column are blue, some are red. This is because we have defined few members as gravity member, few as lateral member. For any high-rise building, framing system is very important for the stability of the structure. Based on the geometry and external condition, we can define different types of framing system: tube structure with single shear core, multiple connected tubes or tube in tube, shear core with peripheral bracing or belt truss. For more details, you can go through IS 16700 or relevant American code. For SARD, a concrete shear core is adopted with connected gravity and lateral framing member. This is a typical floor plan modeled in RAM structural with dual framing system. This shear core is visible in the construction phase picture as well. In RAM structural, we can define different types of framing system with structural bracing and diaphragm. We can define a dual framing system where some members can carry and transfer only gravity load, other carry both gravity and lateral load. This dual framing system is suggested in Indian code for proper seismic analysis. Typically for any structure, we define all the members as lateral member. In reality, central member carry most of the gravity load and peripheral member are subjected to lateral load. By defining separate framing system, this structural behavior can be considered properly during analysis. Not only this, it also reduces the overall material usage in the structure. We have modeled the same structure, first with all lateral member, then with combination of gravity and lateral member, and compared the overall material usage. As you can notice, a dual framing system reduces the material usage and provides a better and economic solution. In this model, most of the central members are defined as gravity member, colored in blue, and peripheral members as lateral member. For floor slab, we can define different framing system: composite, non-composite, or a concrete slab. In RAM structural, we can create a composite deck with metal sheet, shear stud, and concrete slab casted together. This can be designed using American code. Shear stud is considered during rebar calculation. Here we have used a concrete floor slab, which we will design later in RAM concept. RAM structural has different interconnected modules used for modeling and design. RAM frame is used for frame analysis. Load and analysis related properties can be specified here, like the deck slab property. In RAM, we can define 4 types of diaphragm: rigid, flexible, pseudo-flexible, and semi-rigid diaphragm. Provide the out-of-plane stiffness. Pseudo-flexible diaphragm can be used to distribute a fixed portion of lateral force to the orthogonal frames. IS 1893 code suggests a proper distribution of lateral force in different moment resisting frames. Minimum 25% of base shear needs to be carried by these frames. This can be achieved with a pseudo-flexible diaphragm. In this model, we have considered all floor as rigid diaphragm with infinite in-plane stiffness considered during lateral analysis. Apart from different types of framing system, there are several other useful features. We can consider reduced section property or cracked section during analysis. Provide buckling restraint element or durafuse. RAM is equally good for any steel building. We can model a castellated or cellular section in RAM with web opening and design that section using AISC code. Consider this building with both steel and concrete member. Steel sections are used as column along with few concrete member and shear wall. For deck slab, we have used a composite deck along with concrete property. Start dia and length is specified. Showed steel plate is used. We can design this with American code. For any building project, one important aspect is to apply different types of load on the structure with minimal effort. In this model, we have defined few dead and live load case. We can add a surface, line, and point load on the floor plan at any location. For this typical floor, a surface load is defined with different intensity for dead and live load case. Similarly, a line load is added at the external boundary, which represents the external cladding load. RAM structural internally computes the seismic mass from the defined gravity load. This mass is applied at each floor level with proper intensity. We can use these computed values for seismic analysis or edit it for any floor. In RAM structural, lateral load generation can be automated. We can perform both static and dynamic analysis. For static analysis, different codes are available, including AC7, IS1893 and EC8. In the input wizard, we can define required parameters to generate seismic load in both orthogonal axes. Consider combined effect of 100% load from one direction along with 30% load from perpendicular direction for non-orthogonal frame members as suggested in AC or Indian code. As floor diaphragm is already defined in the model, center of mass and center of rigidity are internally computed, and we can consider inherent and accidental torsion during seismic analysis. Similarly, dynamic load can be added based on different design code by providing some inputs like zone and soil factor. We can also automate wind load generation using pressure coefficient method based on AC7, Euro or Indian code. Older version of IS875 is available in RAM. This is a one-click operation. By specifying some basic parameters like terrain category or wind speed input, wind load can be generated in both axes. Program first performs eigensolution to find the mode shape. Based on that, distributes the wind load intensity in all possible directions. For any high-rise building, we need to consider the dynamic effect of wind along with the vortex shading effect. When wind is applied on the structure from any direction, along with the direct pressure load on the projected area, we need to consider the crosswind effect and drag forces in other part of the building. This effect can be captured using a wind tunnel test where a miniature version of the structure is tested for wind application. In RAM, we can directly import this wind tunnel test data as an input. No modification is required. Test data can be imported as story forces in the form of lateral load and moment about vertical axis. During analysis, this is used to compute the structural behavior due to wind load. Also, we can add a virtual workload for drift analysis or construction stage load. I'll cover this later. For analysis, we are using signed response spectra with subspace iteration as eigenmethod. RAM structural supports other method of eigensolution like LDR method, which are comparatively faster if there is any redundant mode. For example, if there is any attachment or antenna at the roof that contributes nothing during seismic analysis, we can ignore this using LDR method and achieve 90% mass participation with fewer modes. Also, we can combine dynamic analysis with nonlinear p-delta analysis using geometric stiffness matrix. For any high-rise building, we need to consider second-order effect using p-delta analysis, which is more accurate than linear elastic analysis. If response spectral load is defined in the model, program use KG matrix to consider the contribution of dynamic analysis along with p-delta. Also, we can consider the effect of rigid end zone, where the member end inside the column is considered as infinitely rigid. High peak moment at the column center is ignored. During analysis, we can select one or multiple load case. Load case selection is optional. If there is any change in any load case, like the dead load intensity is changed, we can select that modified load only and perform analysis. No need to select all load case. Result for rest of the loads will remain constant. After analysis, we can check the results graphically as well as in the report format. Select any member to generate the bending moment or shear force diagram for any load case at any location Also, we can generate a detailed report for one or multiple members. This report includes different inputs for the member and analysis result for each load case. When we analyze any structure in RAM, stiffness method is followed where the stick model is used for analysis, considering member and element stiffness and applied load. During analysis, all loads with full intensity are applied on the structure. This is true for a completed building, but during construction stage, all these loads are not present. Even the load intensity is not maximum. Also, the concrete strength is not at 100%. There are several structural aspects like change of concrete modulus over time, creep and shrinkage deformation, which are directly related to this construction and loading phase. Effect of this on structural behavior along with sequential application of load needs to be considered during analysis. For example, consider this multi-tower building with podium level for commercial usage. For any building project, all portion of the structure is not constructed at the same time and in same pace. Some portion is considered first, then construction work starts at different part. There might be some temporary structure or loads as well. This whole phase of construction with differential load application are considered during a construction stage analysis. RAM structure can perform construction stage analysis with proper input. We can specify the stage number of each phase, in which order a floor is constructed. This can be automated starting from the bottom level. Lower floors are created first, then the upper floors. Even stage number can be assigned to individual member. Construction duration is required. This is the total time spent to cast a floor. Accordingly, program calculates the time-dependent deformation. 3 different types of material models are available which governs the creep and shrinkage related information. When formwork removed, when curing starts, what type of curing method is used. Finally, we need to add this construction stage load for analysis. Either we can consider sequential load application or the creep and shrinkage deformation in the analysis depending on the selected material model. Also, we can replace the dead load result with construction stage result, which is more accurate. We can also perform drift analysis in RAM, which use virtual work principle. For any tall structure, higher drift can cause serious structural damage if not considered properly in the design stage. Also, it causes discomfort to the dwellers. This module can use to identify those parts of the structure which is most influential to control drift. It identifies those members which can minimize the lateral drift with higher stiffness. Also identify the members the size of which can be reduced without increasing the drift. There is another way to create a model in RAM structural. It supports iTwin service. iTwin is a data transfer technology using which we can interchange filtered data between different products. It's like a common basket where anyone can store any information. Structural, architectural, piping or generic data, and access filtered data from other products. Most of our products, including StatPro and RAM Structural, have this facility. Few non-Bentley products like Revit or Tekla also supports data interchange using iTwin file. If an architectural model is created in Revit or Open Building Designer, we can export that as an iTwin file. It can contain both architectural and structural data. We can import this iTwin file in RAM Structural. Only filtered structural data are imported. Architectural data like partition wall information are ignored. Once the model is imported in RAM, we can proceed with load application and analysis. If there is any change in the structural model, like change in member size or orientation, we can bring that data back to Revit or OBD using same iTwin file. Two-way data interchange is possible. Similarly, we can import any StatPro model in RAM Structural for advanced analysis. StatPro supports iTwin integration. We can create an iTwin file from Stat. This model can be imported in RAM Structural and used for construction stage or drift analysis. That's all about modeling and analysis of a concrete building in RAM structural. This model is ready for design. Next, we'll use few interconnected modules like RCDC and RAM concept to design different concrete element of this structure. Thanks for watching.